Hello. In this video, we want to find the derivative of each function. Okay, we've got four different functions here. So the first thing we're going to look at is y equals e to the 5x. Well, if we want to find dy dx, we need to understand, first of all, that the base is e. That means we don't need a natural log for a scaling factor, if you will. So we have e to the 5x, and so because we have e to the 5x, we're just going to rewrite it, e to the 5x. But then we have an exponent here, so we're going to multiply by the derivative of the exponent, and the derivative of 5x is 5. And that's pretty much it. I do like to put the 5 in front, making that 5 e to the 5x. So dy dx here is 5 e to the 5x. Excellent. Let's move on to the next one. S equals 3 to the tth power. So if I want to find ds dt here, first of all, what's the base? The base is 3. That means that there is a scaling factor here of the natural log of 3. And then just work with this like you would work with any exponent. So just rewrite this. So 3 to the tth power times the derivative of the exponent, but the exponent is just the exponent is just t, and the derivative of t is 1, so we have no reason to write it. And there you go. That's the derivative. Now let's look at f of x. So let's find f prime of x here. Well, 10 e to the 3x squared. Now notice that there's a 10 in front, right? That's just a coefficient in front, so just rewrite it. And then we have the base of e, means I don't need a natural log scaling factor. I can just rewrite everything that we have. So e to the 3x squared. And then multiply all that by the derivative of the exponent. Now the exponent is 3x squared, and the derivative of that is found from the power rule. Bring the 2 down in front. 2 times 3 is 6. And then x to the first power, because you bring the 2 down by 1. And then just simplify. Now notice that 10 times 6x we can do, making that 60 e to the 3x squared. And then f prime of x in front. And there you go. Excellent. Now for this last one here. G of t equals 8 times 10 to the 1 over t power. Now before I do this one, I'm going to go ahead and rewrite this. First of all, notice that that 8 is just a coefficient. That's all it is. It's not part of the base. So it's 8 and then 10 is the base. But notice that the exponent is 1 over t. I want to make that t to the negative 1 power. And then I'm going to go ahead and find the derivative. G prime of t. Now again, because there's an 8 in front, I'm going to bring that 8 down. And what's the base here? The base is 10. It's a common base, which means we do actually need a scaling factor here. That scaling factor is the natural log. So it'd be a natural log of the base itself, which is 10, and then treat this like you would have any other exponential. So just rewrite all of this, and honestly, I would write it as 1 over t in the exponent for now. Well, just always. But I rewrote it like this for a reason, because now we have to take the derivative of that exponent. And if you look at that, t to the negative 1, I can take the derivative of. Bring the negative 1 down in front. So that gives me times the negative 1, and then t to the negative 2 power. Because you have to subtract 1 from the exponent. Excellent. And then I'm just going to take this and multiply by the 8, and that's going to give me negative 8 t to the minus 2, natural log of 10, and then 10 to the 1 over tth power. And that would be g prime of t. Excellent. Well, I believe that's it for this video. I'm going to go ahead and end it here, and I will see you in the next one. Have fun.